Good evening, madam. Long time we are seeing.
Yes, yes.
So when is our next Saturday is December, now you have postponed.
Yeah, December 13, I think.
13, okay.
Moulavi, you can start.
Yes, sir. A very warm good evening to all present here. Please make sure that your microphone and video is mute throughout the session. A feedback form link will be provided in the chat box. Please feel free to fill the form and mention your requirement for the certificate in the same. So moving on to the session, a very warm good evening to one and all present here. I welcome all of you to the 84th Intersociety Weekly Webinar Series talk. Today's talk is jointly organized by IEEE Kerala Section, the Institution of Engineers India Kerala State Center, Computer Society of India Trivandrum Chapter, Project Management Institute Kerala Chapter, Internet Society Trivandrum Chapter, Vakkom Moulavi Foundation Trust Trivandrum, Life Member Affinity Group Kerala Section, IEEE Engineering in Medicine and Biology Kerala Chapter, the Institute of Electronics and Telecommunication Engineering. So today we have with us Professor V R Jisha ma'am, PhD, Chair, Robotics and Automation Society, Kerala Chapter. Ma'am will be giving us a keynote on the topic, Robotics and Society. Now, I welcome Rosmi Johnson to deliver the welcome address. Rosmi, please.
Yeah. Good evening, ladies and gentlemen. I extend a warm welcome to all at the 84th talk of Intersociety Weekly Webinar Series. The very first, let me appreciate each one of the attendees for your interest in exploring the opportunities even during this pandemic situation through Intersociety Weekly Webinar Series. This great venture, initiated by Intersociety, has been successfully coordinated for the past 83 talks with honored speakers, and today is not an exception. On behalf of all the attendees gathered here with utmost honor and privilege, I welcome renowned signature of the day, Professor Jisha V R, PhD, Chair of IEEE Robotics and Automation Society, Kerala Chapter, to the 84th talk of Intersociety Weekly Webinar Series. Welcome you, ma'am.
Thank you.
Much delighted, I welcome Chair of Intersociety Activities Committee, Kerala Section, Dr. Harendralal Sir, to the event. Welcome, sir. Next, I would like to welcome all the organization committees and office bearers to this section. Welcome all. With immense pleasure, next I would like to welcome the volunteers of today's section, Amrita, Gokul, Sumaya, and Aishwarya to this section. Welcome all. Once again, my cordial welcome to all to the 84th talk of Intersociety Weekly Webinar Series. Wishing all an insightful and fruitful webinar experience. Thank you.
Thank you, Rosmi. Now I welcome Sumaya to deliver the introduction to speaker.
Hello, am I audible?
Yes, you are audible.
Yeah. I welcome Professor V R Jisha, PhD. Professor Jisha V R joined College of Engineering Trivandrum as a faculty in 1999 after obtaining BTech in Electrical and Electronics Engineering from the same institute in 1995. Subsequently, she acquired Masters in Control Systems from CET and PhD from Indian Institute of Science, Bangalore in 2012. She is currently working as an associate professor in Department of Electrical Engineering, College of Engineering Trivandrum. She has around 30 publications in international conferences and journals to her credit. She is also officiating as Chair of IEEE Robotics and Automation Society, Kerala Section, Member of Board of Governors, Kerala Technological University, Member of Board of Studies, BTech, Robotics and Automation, St. Gitt's College of Engineering, and former convener, Syllabus Committee, BTech Robotics and Automation, Kerala Technological University. I warm-heartedly welcome you, ma'am, to this webinar.
Thank you, Sumaya, and good evening, one and all present here. It is indeed a great honor for me to join with all of you for this 84th session of Intersociety webinar series. So this Intersociety webinar series is considered as one of the prestigious events of IEEE Kerala section. So in that way, I am really honored and humbled to be part of this Wednesday talk series. And I should say hats off to Harinderlal sir and team for guiding youngsters of IEEE by coordinating these kinds of vibrant activities so that the youngsters will also be able to take up many initiatives like this. So with that introduction, so let me move on to today's talk. Let me share the screen. Yes, I hope the screen is visible.
Yes.
It is visible.
So the title of today's talk, I thought of talking something about how robotics is contributing to the society, robotics and societies. That's the title of the talk. So why, see, all of us are very much fascinated, right? Like when we hear the word robots, why? Because no, it is apart from precise and consistent. Robots can work in any environment, adding to their flexibility, and they can be used in dangerous jobs. That is in environments which are dangerous where humans cannot reach, right? And they are also capable of handling heavy payloads multiple times as that of human beings. So they can handle toxic substances. They can do repetitive tasks without any boredom, right? So maybe because of all these reasons, nowadays robots are being widely used worldwide. And it has attracted many researchers, right? Even though they belong to mechanical stream, electrical, electronics, computer science, no? Like people from many streams are working together to build robots which can serve the society. So I thought of taking you all through the current robot statistics. Okay, so the New World Robotics 2020 Industrial Robots Report, it shows a record of 2.7 million industrial robots. So 2.7 million industrial robots operating in factories around the world. So it's an increase of 12%, we should say year-wise. So, and sales of new robots remain on a high level with 373,000 units shipped globally. So we can just have a feel of the market. So, so Indian robotics market was evaluated at 4,564 units. In that year, and it is estimated to grow at around 13.3% in this 2019 to 24. So everywhere that is seen. So this is actually a picture of which kind of robots are being used worldwide. So if you look at this, no, see, this is the class of industrial robots, and this is a class of service robots. So industrial robots means they are all like we call as robotic manipulators. Robotic manipulators means they are arm-like robots, okay? So which are mainly used in manufacturing industry. So you can just imagine car manufacturing industry or something like that. So industrial robots are basically human arm-like robots. And and service robots means they are like mobile robots which are used in warehouses or automated guided vehicles, right? And the robots which are used in outdoor environments and all, no, they are all generally classified as service robots. So if you look at the count, like the number of industrial robots that are dominating in 2015, as well as, see, it is in million, okay, $1 million market. It's the market. So, and see, by 2020, still, if we take the total count of robots, the industrial robot market is dominating, because mainly the robots are being employed in manufacturing industries, and in manufacturing industries we mainly rely on these kinds of manipulators for repetitive tasks. So see another picture of like number of robots country-wise. See, 13.8 billion US dollar value of new installations. 73% of installations in top countries, 5 countries. So this shows the robot density worldwide. So average of 113 robots per 10,000 employees. See, this is the statistics, robots per 10,000 employees. So if you look at this, like Singapore is leading with 918 robots per 10,000 employees. So we could see that the market is growing. A lot of robots are being used. Okay. So this is just a list of another list which shows the annual installation with the countries annual installation of industrial robots. That means robotic manipulators, arm-like robots in countries with the most installations. So in 2019, you could see that around 140,000 units have been installed, and in India around 4,300 units. So you could see like we are in 10th place, but still in India also the count is increasing year by year. So looking at all these, we can understand that the market is experiencing significant transformation, with robots growing beyond the workforce of industrial shop floors. So even though in one snap I've shown that the industrial robots count are dominant compared to service robots, but nowadays we are beginning to adopt the roles of personal assistants, then surgical assistants, delivery vehicles, autonomous vehicles, exoskeletons for rehabilitation purpose of paralyzed people or partially paralyzed people, and crewless aerial vehicles, and among many other uses. So nowadays, the market in this sector is also increasing compared to the industrial robot market. So this is just a class of robots other than the statistics showing class of robots other than robotic manipulators. So in this, we can understand that, see, the medical robots, the medical robots, the count, how the count is increasing from 2018 to 2023. Okay, so maybe the pandemic has also helped in the growth of robots in medical industries. And then logistic robots, also the count is increasing, and these are the ones used in field robots, which are the robots used in outdoor environments. So there is significant growth in the count of robots which are being employed in in hospitals and all. So which are classified as medical robots. This is another picture showing the change in human workers and robots since 2009. So if you look at this one, this one is actually the peach color one shows the manufacturing employment. That is actually the change in human workers. So if you look at this now, in many countries, the change in human workers is actually in the negative direction. And see, this actually shows robots per 1,000 manufacturing workers. So in majority of the places, see, the count is dominant compared to like much higher compared to the number of human workers. Okay, so maybe in future, do we have to witness a picture something like this? Okay, so all the human workers will be replaced by robots. So will that be the future? Okay, we need to wait and see. So if you look at the COVID-19 scenario, we all have seen that as social distancing is to be practiced mandatorily, so this is one of the very good tools which can practice, right, the social distancing. And in many places, we'll be able to employ robots in COVID-19. So this is one of the robots which are employed in Kerala. So we can just have a look at this video.
കേരളത്തിലെ പുതുസംരംഭങ്ങൾക്ക് കൂടൊരുക്കുന്ന ഇന്റഗ്രേറ്റഡ് സ്റ്റാർട്ടപ്പ് കോംപ്ലക്സിന്റെ കവാടം കടന്നെത്തുന്നവരെ സ്വീകരിക്കുന്നത് അസിമോവ് റോബോട്ടിക്സിലെ ഇവർ രണ്ടുപേരുമാണ്. കയ്യിലെ പാത്രത്തിൽ അണുനശീകരണ ലായനിയും ടിഷ്യൂ പേപ്പറുകളും മാസ്കുകളുമായാണ് റോബോട്ട് സുന്ദരികളുടെ വരവ്. മുന്നിലെത്തിയാൽ ആദ്യം തന്നെ ലോകാരോഗ്യ സംഘടനയുടെ മുൻകരുതൽ വീഡിയോ കാണിക്കും. കോവിഡുമായി ബന്ധപ്പെട്ട സംശയങ്ങൾക്ക് സായാബോട്ട് മറുപടി നൽകും.
How will I protect myself from coronavirus?
Avoid close contact with other people's. Avoid touching your eyes.
So this is actually a robot which was built by Asimov Robotics. And this is called Saya bots. So robots of this sort can be, we can use them widely in many places, right? Shopping complexes or industrial environments also, where instead of a security personnel, we can deploy these kinds of robots. So this is an example where in Kerala also these kinds of robots are being employed. So this is another scenario of wherein you could see ICU beds where frequently the doctors have to monitor the conditions of all the patients. So each and every time, see, if with the help of, if we could employ these kinds of robots, the doctors may not have to frequently come near the persons wearing the PPE kit and monitoring the conditions, the temperature. And see, already we know that there are many devices connected to the patient, and many of the parameters will be displayed in the monitor. So, and the main parameters can be transmitted or see through this. This can monitor, and that can be transmitted through the doctor, and he'll be able to analyze. See, instead of wearing PPE kit, easily they'll be able to see. It's not that completely we can operate all these ICUs with robots, but in between, we'll be able to deploy them too. So this is another scenario where food is being delivered. So this is a scenario in Tamil Nadu where a robot was being used to deliver food to the COVID affected patients in COVID ward. Okay, so which could also ensure social distancing. No one has to wear PPE kit and go and distribute these kinds of or medicines or food material. So this is another scenario. One at Bangalore.
Hi. Name please.
Sharat Kumar.
Phone number please.
9030-300-300.
Let me check your body temperature. Please take a step back and look into the camera. Your current body temperature is 100.8 degrees Fahrenheit. Do you have a fever, cough, throat pain or difficulty in breathing?
Yes, I'm feeling feverish.
The screening is complete. Now you will need to go to flu clinic for further assistance.
Hi, Sharon. I see that you have fever with high temperature. Let me connect you to the doctor.
How are you today?
I'm feeling feverish, doctor.
Do you have any throat pain or breathlessness?
No, doctor.
It looks to be normal fever and not COVID. Mitri will issue the entry pass for you.
Thank you.
Please collect your pass and proceed through gate number 2.
Yes, we could see that, at many places, human intervention could be avoided and easily, like many stages of scanning was over with the help of this robot. Even the admission ticket was issued by the robot. See how it is helping us. See, this is so the scenarios which I mentioned previously, those are all hospital scenarios. See, in the current context, current context, see the applications of this sort, like self-driving home delivery system. So that will also be like one of the useful application, I should say. So which we can also try to adopt in future. So you can just have a look at this one. It's able to avoid obstacles also. So it's reaching the destination and see how easily delivery was of the packet was happening. So maybe this can also be the need of the day for us too, and we need to think of delivery systems like this sort as well. So this is another scenario wherein the delivery is being done using drone, which are referred to as aerial robots. Like, see, the previous case, we can rely on when the distance is not much. Maybe in a flat complex or a residential area, we can think of the previous one. But if the distance is more, we can think of a drone delivery system. But see, in India, the scenario is totally different, we should say. Maybe the rules and all have to be changed if we need to adopt this kind of a delivery system. So this has been already implemented by Amazon. demonstration of how the packages delivered via drone system. So for all of us engineers, there are so many challenging tasks. So if you look at all these examples, whether you are a mechanical, electrical, or electronic or computer science engineer, there are a lot of research problems which are open for all of us. And there are many challenges in the mechanical design part, the actuator selection, the control part, the path planning, the guidance. So there are a lot of problems, which are to be solved. Like, if we look around the Indian scenario, we could not see these many kind of applications. Maybe in future we can witness many more applications like this. So this is a robot which is being employed for deployed for elderly care. So we could see that there is an increasing population with special needs. So this also we may be able to witness in future.
Would you like to dance with me?
Yes.
This song is In the Mood by Glenn Miller.
Basically acting as a companion.
What we wanted to do was design a robot that's easy to use.
The time is 9:39 a.m.
Designed specifically for seniors, but also affordable. I think that was very important. It's something that seniors, older individuals could trust.
He's company, and there's somebody to talk to, and somebody to dance with. I like the song that he plays, actually.
Okay, Rudy.
What would you like me to do?
Help me.
Have I reached you? Remember to take your morning medication, Anthony.
We always had seniors involved, and every time we had some type of communication, we'd introduce it. Seniors would give us their feedback, oh, we don't like this, we don't like that. We'd come in and change it.
Okay.
At an early age, I saw both aspects of it, and as I grew older, I realized we weren't the only family facing this problem.
Let's go.
There are thousands of families facing the same issue, most cases even worse, where they have a loved one that they're taking care of, and the cost becomes an issue. So we don't want to make decisions for them. We want to help them make decisions and really give the power back to them so that they can stay independent.
Hi, good afternoon.
So this is able to communicate with people who are far away, and they are able to, these kinds of robots are able to maybe deliver food and medicines also to elderly people, and also it's also giving company as well at times, and also reminding them of taking medicines as well. So the number of robots which are deployed for this elderly care is also being increased nowadays.
You take your medicine?
So in one of the slides, I have shown how the number of robots which are used in medical industry, or which I termed as medical robots, is increasing. And nowadays, robots have coined a term called Robotics, wherein the robotics associate or automation part, which is associated with medical industry, is termed like this, Robotics. So starting from consultation. So if you look at a video like one of the Fortis Hospital, the robot which was employed there in that video, the primary consultation, you could see that is being done with the help of that robot, right? and the initial diagnosis too, like the preliminary, the primary symptoms, no, the initial diagnosis too, also the robot is capable of doing. Okay, maybe at like if you think of adding more autonomy or artificial intelligence to the system, it will also be able to prescribe medicines as well. So maybe in future we can see these kinds of robots be used in for prescribing that too. And all of you may be knowing that nowadays in many hospitals, robots are being used for surgery also. Maybe initially many are hesitant because we are very much relying on doctors only, but for that is for surgeries. Nowadays, in many hospitals, doctors are relying on that, but it will be assisted by doctors, not like 100% autonomous surgery. So that is one class where robots can be employed. And see, for rehabilitation therapy as well after surgery, so we commonly see that if we have a hand fracture or leg fracture, after maybe 2-3 weeks, we need to start physiotherapy, right? So for physiotherapy, initially generally we rely on physiotherapists for these kind of rehabilitation therapy. So which every time we won't be able to afford. So in that scenario, we can rely on the robots which are employed for rehabilitation, and they can train us maybe how our hands are to be moved or how our legs are to be moved, and we'll be able to recover faster. Right. So nowadays, many robots are being used for rehabilitation therapy as well, and many pandemic-related use cases, right, like sanitization, and some of the scenarios which I have already shown, the ICU, the patients in ICU, monitoring of those patients, right? So all those can be so in that case also robotics plays a very good role. And in telemedicine also, that's already there. I think even Kerala government has introduced this kind of telemedicine system recently in Kerala when we were passing through a complete lockdown and all, right? So, so definitely there is going to be a boom in this industry, medical. So we'll be able to see many robots in medical robots or which are used for these kinds of applications. And see what is going to be the future. See, because of the technological developments, we can see that the cost of robot will be declining, maybe approximately 10% per year. Because earlier we have not seen now maybe you all are aware of a Roomba robot, which are room cleaning robots, right? Now it is available at affordable rates. Many of us are using that robot, but earlier we were not at all aware of that. Maybe because of the cost, but the product price is decreasing, and within the next decade, we'll see specialized robots with vision and high precision dexterity, and there'll be drop in price for those kinds of specialized robots also. So along with reduction in cost, growing capabilities will make innovative uses of robots possible. So even though initially we will be hesitant in procuring these robots, in future we'll also be forced to buy these kinds of products, I think. So we'll see robots increasingly take on manual tasks in manufacturing, packaging, warehousing, and maintenance. So everywhere, we could see, we'll be able to see many more robots which are being employed. But maybe I can say that like in future, during our IEEE EXICOM meetings or IEEE AGMs, we could see these kinds of robots which are helping us in delivering tea and all. So I think maybe in 10, 20 years, we'll be able to, the younger generations of IEEENs will be able to see these kinds of scenario, I think. So what are the challenges like when the number of robots are increasing, the human-robot interactions are increasing? There are many challenges coming up as well. So we need not forget that part of it, right? There can be issues of privacy because like just imagine we are using robots for elderly care, and like maybe like our parents are using this and no one else is there, and see there's a camera which is attached to that, and if someone else and see it is actually connected to the network also. So like as in computer network security, in this case also there can be problem, like if someone wish to intrude into and okay, look at the surroundings, whether it's okay, whether I can come and steal something. Okay, that kind of like, there is going to be issues of privacy and manipulation, opacity, and bias. Like like you cannot say that, okay, it is 100% safe. So in that scenario, like so how can we how we can overcome those kinds of challenges? So generally we can call them as a number. Generally there can be number of ethical challenges. See, for robots to work properly, they are like a lot of data may be required, and generally then like when we think of including AI part also, when we are trying to make it more and more autonomous, we need more and more data. Okay, so so this can be an example of spatial data from sensors. Okay, so where am I? Okay, these sensors will be giving the answer to the question, where am I? So that information is available. The use of cameras and cameras to detect and recognizing people, and data necessary for deep learning with the use of AI. So when intelligence is more data will be like processed, and which is actually if someone is intruding into the network, they'll be able to hack that data and misuse it. So definitely it should follow, it should comply with the general data protection regulation, as in the case of computer network. So we need to think of like whether we can reduce the quality of data. Or not quality of data, like the data minimization. So with minimum data, can I get the required information for respecting the privacy of person interacting with the robot? So there are a lot of challenges you could imagine, but no, like it should not affect the functionality of the robot also, right? We need to get things done with that robot, but and there should be data so it's kind of a conflicting scenario, but still scientists and engineers may have to solve all these problems as well. And what can be the answer to that? So we need to like pursue a responsible research and innovation. So the ethics must mandatorily be followed, but still in every, so everywhere we know that there are positives as well as negatives. So in this case also, like if someone purposely wishes to intrude into and steal data and try to harm you, that can happen. Okay, so but generally, like we are the masters. See, who's building all these kinds of robots? We are building them, right? We are providing intelligence to them. Okay, so what we can do is like, okay, if some kind of worst case scenario is happening, like, okay, some extreme conditions, okay, are happening, no, like definitely the stop button should act. That programming should be, that programming will definitely be there, especially in all these service robots, right? But no, like if there are people who wish to purposely intrude into, there can be problems. And there are potential research areas as well, like considering all these facts, right? See, anyway, in future, we are going to meet and interact with a lot of robots. But in the other side, no, like these kinds of ethical issues are there. We need to resolve all these, right? So even with the technological advances, but still robots are unable to match the depth and breadth of human perception. So still, no, a lot of work to be done. And significant challenges persist for more complex perception tasks, just such as identifying objects and their properties in a cluttered field of view. Maybe in perfect environments, it will work, okay. But like in a cluttered environment, that may fail, okay. So therefore, an unstructured work environment can make these jobs less likely to be taken by robots. So unless scientists and engineers are solving those kinds of problems, still there'll be a lot of tasks which only humans will be able to take up. Okay, so this is one of the works which we took at CET. So this was an interdisciplinary project which was taken up by Electrical and Mechanical Department of CET, which is referred as Human Operated Exoskeleton. This is a kind of a wearable exoskeleton which can support partially paralyzed people. So let's just play that video.
Upper limb paralysis is a leading cause of disability in India. Over 1.8 million Indians suffer from stroke every year, and at least 10% of all patients injured in road accidents suffer brachial plexus injury and spinal cord injuries. The physiotherapy needs of the patients are unmet due to lack of required number of qualified physiotherapists.
So we did in collaboration with the IC4s. See, Arshad is actually is a kind of semi-paralyzed. He's not able to move.
The project started as a mini project by Arshad A. Samad and Menino Fruto of MTech Robotics and Automation 2016-18 batch. CET Center for Interdisciplinary Research later collaborated with IC4s to realize a final prototype.
This exoskeleton can work as a wearable physiotherapeutic assistance for those who are suffering from upper limb partial paralysis disorder. It is having 5 degrees of freedom and it is controlled to sync with the natural movements of the user.
So you could see that he's able to move his hand. Actually, no, he could move only a little bit, but using this now.
To make it wearable, 90% of all the parts were made using 3D printed lightweight materials. To start with, we tried to address the physiotherapy needs of one of the team members who was suffering from the brachial plexus.
See, he was actually unable to lift his hand beyond a particular point, but using this, no, he was able to move it in a normal way. So definitely, no, these kinds of robots can be used for rehabilitation purpose. For partially paralyzed patients, no, like see what generally a physiotherapist does. So that kind of movements, no, initially the patient will be able to take up, and later, no, he'll be able to move his hand in a regular manner. Okay, so see one of the works which we took up.
Plexus injury.
And the last question, which I will ask everyone, is: will the robots take over? Okay, so what do you all think? So I would say that so even though some experts are predicting that the robots could take over more than 20 million jobs worldwide by 2030, a lot of humans will be unemployed. But see, our cities are connected, our homes are becoming smarter and smarter, and our business is going to be more efficient. And but it will have the ability to change only subset of our world, and which primarily includes jobs in more structured and predictable conditions. Okay, but when the environments are changing, and when there is some randomness or some uncertainty, so there can be challenges, right? So there are still many industries and workflows that may need humans. So even though the number of jobs for humans are the employees are reducing, mainly they will be employed instead of the maybe the primary task of packing or something like that they may be doing. Maybe they have to shift their job to maintenance and repair of these many robots which are being employed in industries. So the nature of job may change, but definitely there will be job opportunities for many of them. So I should say, so this is by Rod Grappen. See, at bottom, we should say robotics is about us. See, it is the discipline of emulating our lives, of wondering how we work, right? So actually, this creation, I don't know when this is going to happen, but partially, we are trying to mimic, okay, how we can mimic the movement of our hand. So now you might have seen how the exoskeletons are helping the people who cannot walk. They are able to walk wearing these kinds of exoskeletons, right? So different parts we are trying to understand more and more, and trying to understand more about that, and trying to recreate like this. And so with this message, I'll be concluding today's session. See, one machine can do the work of 50 ordinary men, but no machine can do the work of one extraordinary man. So still, humans will be dominating, because we are the masters are in programming or making these robotic systems autonomous, right? So in that way, definitely we'll continue to be masters in future too. So that's what I wish to convey. And with that, I'm concluding, and thank you all for patient listening. I think there are...
Thank you, ma'am. Thank you so much, ma'am. It was really informative, at the same time very interesting. Thank you so much, ma'am. Ma'am, we're having a few questions in the chat box. Ma'am, can I read out the questions for you?
Yeah, sure.
Ma'am, first question. Ma'am, whether COVID creating virus knew that mankind can still survive because they have robots to take care of themselves, even in the presence of COVID virus. Moreover, it is an opportunity for mankind to test and prove their inventions on robots. It appears to me so. Ma'am, your views, please.
Sir, I don't know whether COVID creating virus knew or not, but still, see, it is proven that whatever be the challenge coming before us, humans are able to resolve many of them. So see, initially, flood came. So we tried to come up with many strategies to come out of that trauma. Many were left homeless, but still, we all work together to come out of that. And there also technology helped. And in this case also, we could see, like in many places, the automation and robots have helped us a lot.
Thank you, ma'am. Ma'am, next question. Ma'am, what is the probability of robotics hitting back due to some malfunction?
No, generally that will not happen, because if we have to use these, so that it has to follow some industry standards, right? So definitely it has to follow some industry standards. So like there will be definitely double or triple layer protection mechanisms which will be available. So generally, when we are working with industrial robots, like only when in the what will we say, the HMI, human machine interface, which we are using to operate a machine, like only if we hold two switches together, the machine will work. Okay, so only if one switch is on, the machine will not work. Okay, so definitely, if one fails, there will be a secondary mechanism, tertiary mechanism, which will be helpful to like stop all the actuating mechanisms or moving mechanisms. So then only we'll be able to like deploy them either in industries or in or as a service robots. Okay, so this I could say, because like when we started working with exoskeleton, so we didn't know that like initially we didn't know that we need to get approval from the doctors, the biomedical experts. So there should be many clinical examinations, like many trials before that is being actually used in like for a rehabilitation purpose. So later we came to know that only if all these tests are passed, you will be able to use them for a practical purpose. So definitely, definitely those kinds of mechanism will be intact if it has to be used, like if it is interacting with human beings, definitely.
Thank you, ma'am. Next question. Ma'am, could you please talk about the building blocks of an industrial robot?
Building blocks?
Of an industrial robot.
Okay, so like industrial robot is basically, as I was mentioning, it's like our human arm. Okay, so it will be basically having links, we should say, which are rigid bodies. Like you could see these kinds of rigid bodies connected by joints, I should say. Okay, so we say that if you look at our elbow joint, so this is having only 1 degree of freedom. But so if you look at the wrist, it is having more degrees of freedom, right? I could move like this, like this. But so if you try to imitate this joint, like I need only 1 motor for this. Okay, so we need to think, okay, so basically, first of all, I'll tell the components. So they are links, joints, and if you have to make it autonomous, we need sensors, because we need to know how much it has moved. Okay, or if I have to pick something or do some task, some camera should be there to okay, position it perfectly. So sensors are there, and plus controller. Okay, so these are the mandatory components, or I could say the main building blocks of an industrial robot. So while we are trying to implement them, like for this joint, for example, I'm telling, I need only 1 motor. But if you look at the shoulder, it is basically having 3 degrees of freedom. Like I can move like this. So in 3 directions I can move, right? So I may have to use 3 different motors there. Otherwise, like you can either use motors, any actuators you can use. Okay, so the actuators can be as I was mentioning, can be electric motors, like servo motors, stepper motors, or DC motors, even BLDC motors. And also like some in industries, like if you look at car manufacturing industry, you could see that the robots are lifting a car. But generally, if it has to lift a car, that means the payload is too much. So there, no, in that scenario, we cannot use an electric motor. So in that case, no, hydraulic actuators are better. Okay, so if payload is too much, no, we need to go for hydraulic actuators. And in some, so suppose you just imagine a case of food processing industry where robots are being employed. So there, no, we can rather go for pneumatic actuators rather than hydraulic actuators, because no, hydraulic actuators, there's a possibility of leakage of oil, so which can contaminate food. Okay, so depending on the industry, the requirements, we need to choose all those actuators. So these are the main components of a typical industrial robot, or we can say robotic manipulator.
Thank you, ma'am. Next question. Ma'am, in Kerala, introduction of robotics is improving productivity. The problem likely to come up is people lose employment. This can create labor issues in our state. How can such problem be solved? What I meant is the introduction of industrial robotics. Please note.
Yes, so this already I have mentioned, sir. Even though like there are good, like if you look at Kerala, no, like there are not much not many industries, I should say, as in other states. But still, no, like in the industries we have, definitely, even though there's less employment to the conventional job which they are doing, there are going to be many other jobs which they can take. Definitely, they cannot move on or with the knowledge they have, or with the tasks, what should I say? See, if they are capable of doing only that task, no, they won't be able to survive. So they should be trained to do, like maybe the maintenance, or the repair, or just the operation of all these devices, right? So, but we should welcome all those kinds of changes, because there can be repetitive tasks. See, repetitive tasks, when we are doing, the precision can be less, the accuracy can be less, but the robots can tirelessly, they can work for hours without boredom. They don't need any air conditioning. They don't need any ventilation or something like that. No, they can work for hours, and it's going to increase productivity also. So definitely we need to choose the plus points, but it's not that all the employees should be sent out, but they should be trained in other domains so that they'll be able to support the system for improving the productivity.
Thank you, ma'am. Next question. Ma'am, please elaborate on the advantages of robots in surgery applications.
See, what I understand is that some of the complicated surgeries, are taking 6 hours, 10 hours, 12 hours, like that. Okay, so so I have heard from doctors that even a simple mechanism, okay, even a simple mechanism which can support their hand. See, I was talking to one of the neurosurgeons in a medical college hospital. So what he was telling, we don't want a completely automated mechanism. So if you can just devise a mechanism which will adjust its height and position depending on how our hand is moving. Because everywhere you cannot have a support system in just an operation theater. So even that kind of support, will support in automation part or robotics part is going to help the surgeries. And coming on to the typical robotic surgeries. So some, I will not say that the complete surgery should be done by robots, but definitely if some part is automated, definitely it will be helpful for the doctors. It's going to be very tiring, because completely 6 hours, 10 hours, one has to concentrate on this surgery. It has to be done with such a care. So some of the repetitive tasks, can be automated with the help of robots. It's not that we need to rely on robot for 100% of the time, but at least for some percentage of the time, if it can be supported, the efficiency of the doctors will also, because otherwise they are exhausted, they are tired. So these kinds of things, simple mechanisms can be incorporated, which will help definitely the outcome of the surgery.
Thank you, ma'am. Next question. It's unfortunate that highway collision avoiding feature by proper warning, particularly at high speeds with inadequate braking distance to driver or providing driver to note those for split second and cause accident are not being developed and incorporated in automobiles. I'm thinking in this regarding in India.
Yes, sir. Actually, nowadays, many industries are working. So even in Technopark, Tata Elxsi is working on many of these features. And I know another industry which is called KPIT. They are also working in these kinds of systems, wherein they are trying to make some parts or some tasks they are trying to automate, and so they are also trying to include these kinds of safety features so that accidents can be avoided. So many industries have taken up these kinds of like research problems, and they are working on it. It's not that it's completely not taken care of. People are definitely working on these kinds of problems, trying to automate. It's not even though fully automated vehicle, but still, so Tata Elxsi has brought a fully automated vehicle, but that is in controlled environment. And they are trying to, I think they have already implemented an autonomous parking system. They have already implemented, and these kinds of work is also happening there at Tata Elxsi. So that means many companies have taken up these kinds of problems.
Thank you, ma'am. Next question. Ma'am, how to make a 3-axis CAM software for a custom process, a new process?
No, you meant 3-axis robot or like how to make 3-axis CAM software? I didn't get the question.
It's written that how to make a 3-axis CAM software for a custom process.
Yeah, I could see that question. But if it's making a 3-axis robot, no, I can explain, but I don't know 3-axis CAM software. Like if you could elaborate, that will be good.
Okay, ma'am, then we can move on to next question. And what are the projects currently going on in CET and funding agencies?
Sir, actually, as we are having a new stream in robotics and automation, which is an interdisciplinary master's course, jointly offered by electronics and communication, electrical and mechanical. We have students of these 3 streams mainly, and many have taken up good projects trying to automate vehicles and driving assist systems. There are many works which are taken up, but they are all in prototype stage, I should say, because we have started MTech just 4 years back, and the last two years, because of pandemic, we couldn't take up many hardware projects. But funding is nowadays not at all a difficulty, because we are getting, many of the faculty of CET are getting CERT funding. If even BTech students have taken up CERT funding, and for BTech students we can get up to 50,000 rupees, 50,000 funding from CERT, and for seed money, big research projects, we can get up to 2 lakhs from CERT. And in addition to that, like many of the faculty have taken funding from KCST and DST funding also. Many of the faculty are they have applied and they got funding also. So many of the many teams have come forward jointly, mainly interdisciplinary projects as well as department projects, and they are getting funding too. And what we have done is we jointly worked with IC4s to come up with that exoskeleton project which I was explaining.
Thank you, ma'am. Ma'am, next question. Is the robotic arm manipulator control automated, the CET project?
No. Even though we started, we started the project in that way to make it fully autonomous. See, we couldn't complete that part. So what we did is with some control key mechanisms, we try to move it. You might have seen in that video using joysticks. The arm was being controlled. And we actually plan to come up with motion intention detection also. Like suppose if someone is semi-paralyzed, he's trying to lift his arm. So with that, with the help of 4 sensors, we'll be able to understand okay, he's trying to move his hand up. So that motion intention is to be predicted, and in that direction, the arm is to be moved.
Thank you, ma'am. Ma'am, next question. Ma'am, can you please comment on the risk of aerial robots proliferation?
I didn't get that question.
Please comment on the risks of aerial robots proliferation.
Proliferation, I think. Okay. Okay. So, see, currently, I think we are not allowed to, so we need to get special permission. So earlier, some of our students have worked with drones and all. So they try to implement, drones for vehicle tracking and all, but initially we did without getting any permission and all. Recently, Kerala police have come with many norms in order to, if you have to start working on aerial robotics. See, in that case also, so definitely if we have to use all these drones in a crowded environment, definitely many protective measures are to be taken. Okay, so otherwise, if it doesn't pass all those safety standards, that will not be allowed to see, nowadays, you will be knowing, in marriage functions, in almost all the marriage functions, you will see some drones, right? So they are all of standard companies, and they have all passed some, all have some safety standards. Otherwise, you cannot use that. So nowadays, more because people are misusing that, so many accidents are happening. So definitely the conditions are more tight, I should say.
Thank you, ma'am. Ma'am, next question. Like a CEO of a company, is there any super robot to monitor the proper functioning of all robots in an industrial floor?
Definitely, yes. Is there any super robot? Is there? Yes, definitely all that. So you may be aware of a SCADA system wherein supervisory monitoring of all the devices is possible. Because from all, see, the status is monitored from all the sensors, right? So if there is some malfunctioning, or if how many robots are not working, how many are working, so all these status can be known with the help of sensors. So definitely, if you think of industries which are fully automated, there will be thousands and thousands of sensors, and this will be able to give the status. Okay, so based on the conditions, okay, suppose for robot number 15, none of the sensors are giving some reading. So that itself means that what? Okay, this robot is not working, right? So in that way, we'll be able to know that, okay, this is working or this is not working. So definitely status can be known.
Thank you, ma'am. The last question. Ma'am, in extra high tension lines power, engineers do hotline maintenance. Will a robot can be engaged in such risky job in future?
Yes, sir, definitely. I think we will be able to do that, but still, as aerial robots are highly unstable systems, it's not easy as in the case of mobile robot or robotic manipulator, which are by default stable systems. But aerial robots are highly unstable system. Definitely in future, we'll be able to see aerial robots which are being used for those kinds of tasks.
Thank you so much, ma'am. That was the last question. And thank you so much for answering all the questions beautifully and spending all your valuable time here. Now I welcome Aishwarya to deliver the vote of thanks. Aishwarya.
Thank you, Amrita. Am I audible?
Yes, you are.
Good evening, all. Thank you for attending today's 84th Intersociety weekly webinar series. First off, I would like to express my heartfelt gratitude to our keynote speaker, Dr. Jisha V R, for such an informative session and also for clearing all the queries raised by our participants in the chat box. Thank you so much, ma'am. Next, I would like to thank all the organizations involved in our initiatives, and I would also like to thank our role players for today. Our Zoom master, Gokul. Our MC for the day is Ms. Amrita Aravind. Sumaya for introduction to the speaker, and Ms. Rosmi for the welcome speech. Thank you, guys. Last but not the least, I would also like to thank all the attendees present here for your time and cooperation. Hope you all had a wonderful time here, and thank you so much. Over to the MC.
Thank you, Aishwarya. So this is our next 85th Intersociety weekly webinar series talk. The topic is demystifying maths, and it will be given by Dr. Arun Janardhanan, sir, PhD. So I welcome all of you to our next talk and see you all on next Wednesday. Thank you. The meet is officially dispersed.
Thank you,
Thank you,
sir.
Professor Jisha.
Yeah, thank you so much, sir. It's indeed a great
very
honor.
insightful presentation on robotics and how it is affected on the
Thank you so much, sir.
society. Yeah.
Thank you very much. Excellent presentation.
Thank you so much, sir. Sir, actually, see, people like Harindrala sir are doing a lot of things, we cannot sit idle, We too need to do a lot of things.
Yes,
we see the future IEEE in people like you.
And we expect more sessions from you.
Thank you so much. Thank you. I think Chandramohan sir was there. I think some in between.
He was there. Dr. Surendran. Our Surendran sir was there.
Okay. I have not seen. Yeah. Okay.
Yeah.
Next topic is a very interesting topic on demystifying maths. Many of us may not be knowing the intricacies of each problems. This man is an expert on this one. I request all of you to attend this program. Very insightful program on maths. Most of our things will be solved there. So he will be simplifying all those math principles like that. Okay. I heard that he has presented some talks on under the Madras section. Very much appreciated. So I specially invited him to, and he was very much willing to give a presentation. I request all of you to attend the program. It will be useful to all of us. Thank you very much.
Thank you all.
Have a great day. Have a great time. See you next week. This time for the 85th talk.
Yeah, thank you, sir. Thank you all. Yeah, Muhammad Qasim here.
Thank you.
Yeah, bye.
Thank you all.
Yeah.
Aishwarya, you may close it.